Good day and welcome to today's class. Today's class is a continuation of our previous classes on set theory. In today's class, we shall be taking some exercises on set operations, that is, on the union and intersection of sets. Example 1 says, we should find the 1 union, 2 intersection of the following sets. A, we have elements 1, 2, 3, 4, 5 and a set B of elements 1, 3, 5. We have been asked to find the union and intersection of both sets. Let me call this set A and set B. 1 is requesting us to find the union of A and B. That is A union B. And the union of two sets, A and B, is said to be a set that contains all the elements in A and B without repetition. So the union of two sets A and B is going to be 1, 2, 3, 4, and 5. And in this case, I will say that the union of A and B is equivalent to set A. B says, 2 says we should find the intersection of set A and B. That is A intersection B. A intersection B is equal to, remember, the intersection of two sets are those elements that can be found in A and B only. So comparing A and B, we have 1 to be in A and B, 2 is not there, we have 3, as well as 5. So A intersection B can be said to be a set 1, 3, and 5. Also, I can refer to set B to be equivalent to the intersection of A and B. Example 2, B says we should also find the union and intersection of these two sets. Let us equally call this set A and set B. I would like you to equally work it out with me. What do you think will be the union of set A and B? If this is set A and this is set B, what do you think will be their union? Union means all that is in A plus all that is in B without repetition. And if you look at it, we have U, V, W, X, Y, and Z, which is also equal to set A, because we have, if you look at the sets in this union, the set of elements in the union of A and B are said to be in A or B. While the intersection of these two sets, just like I said in the previous example, is said to be those sets of elements that can be found in A and B only. So I think the same applies to the first example, that U, W, and Z are said to be elements of that set, that is A intersection B. C is defining, we have to find the union and intersection of both sets. In A is defined as multiples of 2 less than 12. So all you need to do is to first of all write out the elements in set A, which is defined as multiples of 2 less than 12, and the multiples of 2 less than 12 includes 2, 4, 6, 8, and 10. While set B is also defined as multiples of 3 between 10 and 30. Multiples of 3 between 10 and 30. Once you get the first multiple, keep adding 3 to it, and that gives you the corresponding that gives you the sequence of multiples of 3, and you ought to stop at the last multiple before 30. So this becomes the first multiple of 3 after 10 is said to be 12. We have 12, we have 15, 18, 21, 24, and 27. Yes, these are the multiples of 3 that falls between 10 and 30. Now we are asked to find the union of these two sets. That is, A union B will be equal to, remember, union means all that is in A plus all that is in B without repetition. So I'm going to write them in ascending order. This becomes 2, 4, 6, 8, 10. Then we have 12, 15, 18, 21, 24, and 27. Remember, union simply means all elements in A and all elements in B without repetition. But as it stands, there is none that is being repeated here. So you write out all the elements you can find in A and B. While 2B is requesting for A intersection B, and A intersection B is talking about those elements you can find only in A and B. And by comparison, there is no element you can find in A and B. So we refer to the intersection of both sets as an empty set. So intersection of these two sets is said to be an empty set. Question 3 says, D says, days of the week starting with M and months of the year starting with M. So let this also be a set A, which is defined as days of the week starting with M. We have Mondays, Monday, Tuesday is not, Wednesday is not, Thursday, Friday, Saturday, Sunday. So this set contains only Monday, while set B is said to be months of the year starting with M. Also list out all the months of the year starting with M. January is not, February, March is one. So we have March, April is not, May is another, June, July, August, September, October, November, December. So these are the only months beginning with letter M. The question is now requesting us to find the union of A and B. And the union of A and B is said to be a set of elements Mondays, March, and May. So this is said to be the union of these two sets. While the intersection A intersection B is said to be an empty set, because there is no element that is common in both A and B. Let's take another example. E says a set of elements X such that X is a factor of 18. X is a factor of 18. And the second element X such that X is a factor of 30. Now, what do you understand by factors? Factors are said to be smaller number that can divide a big number without remainder. So, we'll first of all list out the factors of 18 as well as the factors of 30, and then carry out such operations on them. So, set A is defined as a set of elements that is a factor of 18. And what are those smaller numbers that can divide 18 without remainder? We said 1 is a factor because 1 can divide 18 times. So I will say 1 and 18 because 18 is also a factor of itself. Also 2 is a factor of 18. 2 can divide 18 9 times. So if 2 can divide 18 9 times, it means 9 can also divide 18 2 times. So both of them are said to be factors of 18. 3 can divide 18. 3 can divide 18 6 times. Is 4 a factor? 4 cannot divide 18. 5? No. So these are the factors of 18. That is 1, 2, 3, 6, 9, and 18 itself. Set B is said to be x, so that x is also a factor of 30. 1 is also a factor of 30. That is 1 and 30. We also have 2, 2 and 15. 3 can go, 3 and 10. And 4 cannot go. We have 5 and 6. So these are said to be the factors of 30. Now let's carry out the operations on them. We have A union B, meaning all in A plus all in B without repetition. So we have 1, 2, 3. I'm writing them now in ascending order. 3. We have 5. We have 6. No 7. No 8. We have 9. 10. 15. 18. And 30. So these are said to be elements in the union of A and B, while A intersection B is said to contain elements 1, 2, 3, and 6. So these are elements that you can find in A and B. That brings us to the end of today's class. In today's class, we looked at exercises on union and intersection of sets. If you are still having challenges in union and intersection of sets, I would advise you to go back to the previous videos as displayed on the screen for more understanding on set operations. Thank you and do have a nice day. Don't forget to watch our videos and share with your friends so that everybody will get to learn new things. Goodbye and have a nice day. Thank you.